Okay. Sorry for around for here. I forgot my cable in the other classroom last Friday. So I put up a new seating chart on Canvas based off responses. I think that we can get everyone in here. Well, so this week I put up the seating chart, which I'll just pull up here so everyone on Zoom can see what I'm talking about. So notice it has group 1 and group 2. So group 1 this week will be able to show up Monday and Friday. Group 2 can only show up on Wednesday. Next week, I'll repost this just as a reminder, but next week, group 2 will be Monday, Friday, and group 1 would be Wednesday, right? So I didn't get enough people that didn't want to show up that you could all be here, say, twice a week, but enough people so they're not going to be attending in class, in person. So I can create 2 groups, but obviously we have 3 days a week, so we have to alternate. So if you're in group 1 this week, you can attend class Monday and Friday. If you're in group 2, you can attend class on Wednesday, and then next week it'll flip-flop. Next week, group 1, you'll be only on Wednesday. Group 2 will be Monday, Friday, okay? Hopefully for those of you who want to show up in person, that allows you to get a little bit more time in, in-person class. If I have people kind of start to drop out, I'll let you know. I think also moving forward, I haven't counted, but there's so many people that every day are telling me they have to quarantine that we might be able to get you to show up every day. I just have to cross-reference the names, and I haven't been able to do so yet. Like I said, I was getting emails this morning. So as of last night, I wasn't able to kind of figure that out. So if there is the opportunity for you to show up more than kind of what even this has, I will let you know. I'll put an announcement out on Canvas once I cross-reference all those names. Okay? Any questions before we kind of get going here today? Let's see, there's nothing in the chat. Okay, so here's this. Let's go. As a reminder, last week where we kind of left off was we were doing work in Excel with that COVID blank data file. So hopefully if you were working along, you saved it. If not, the complete version is up there on Canvas as well. You can kind of pull that up and kind of follow along as well. But for today, we left off with these frequencies. Once we had those frequencies, we then just inserted a bar graph on Excel, and that's our histogram, right? Because all a histogram is a bar chart where the original data was continuous. We forced it into these bins, right? And then we graphed it as a bar chart. That's what the histogram title means, right? In 1 second, I'm going to close the door. So, bring it back over here to Mike. So the next thing we're going to do, notice here I have a very similar picture, but now instead of frequencies on this y-axis, I have relative frequencies. So I believe that's where we left off last class. So I'll go back here. I believe last class we stopped at those relative frequencies, right? How did we go from frequency to relative frequency? Does anyone remember? How do I get a relative frequency from a frequency? I just divide by, no one? What did I divide by here? I have 36 out of how many? The total number of observations, right? So all we did with that relative frequency was we took the frequency itself and divided by the total number of observations, right? Which we had in Excel, okay? So I believe this is where we left off. We said a good check is make sure your relative frequencies add up to 1, right? Because we should be counting every single observation, one time here, okay? So another check we could do that I did not mention last class was how did we get the total number of observations? Well, I could actually look here, right, at the row number, and I could just kind of count and see, oh, it started in cell 2, it ends in cell 53, I have 52 observations, right? Or I said if I add up my frequencies, right, use that sum function just to add up these numbers, my frequencies should always add up to the total number of observations that I have in my data set. Now, another good way to check this, because when we're doing these frequencies, one thing we talked about last class we have to be careful about is these equalities, right? If I somehow accidentally put the equalities, in fact, I'll do that right now. Let's say I put the equalities on both the lower and the upper bound of that bin. Now when I copy this down, well, here it didn't work, so there was nothing on the cutoff. But if I would have had, like, say, an observation, and I'll just change it just to show you. Let's say there was a state that had exactly 5,000 deaths. Well, now notice it's counted twice. And it's not actually, now, I'm going to have the wrong total number of observations. So we want to make sure that equality is only on one end. That's what we did last class, so I'll just redo that so we have that in the file. Another good way to check this is there's a formula in Excel called count, right? Now, we used the count ifs last class. All the count function does is count the observation if there's anything in that cell, right? There's no if statements or anything. So what we could do is just select our variable, right? Remember the shortcut, Control Shift, or on a Mac, Command Shift, hit the down arrow. I hit enter. Now notice the count function tells me how many observations, right? How many non-blank cells that I have there. And if I did everything right, when I added up those frequencies, these two things should be the same. So that's just another good way to kind of do a check to make sure you have the count if statements working correctly. Okay? Any questions on that before I keep moving? Let me see, I'll have this open so you can see if something pops up in the chat. I'll just pull up in the chat right now. We good with that? Okay, so the next thing we're going to do is create another column. Actually, I'm going to do something a little bit different than what I have in the complete file, but we'll get there eventually. So notice we have these frequencies, right? And we created the relative frequencies. And if we really wanted to, just a reminder, how would I graph those? I select the labels, I hold Control, I believe on a Mac it's hold Command, and I select my relative frequencies, and then it's simply inserting this column bar chart. Right? Now, instead of the frequencies on the y-axis, I have the relative frequencies. Okay? The next thing we want to do is build what we're going to call cumulative frequencies. Okay? So cumulative frequency, the word cumulative, just like with your GPA, means everything that's happened prior to this time, right? The cumulative GPA looks at this semester and every semester before. So a cumulative frequency will count the number of observations that are in the bin you're looking at and every bin before it, which here would be below it, right? Since we're ranking this from smallest to largest. So for the very first bin, the cumulative frequency is very easy. If the cumulative frequency is the number of observations that are in this bin and every bin below it, well, there's no bins below it, right? So the cumulative frequency would actually just be whatever that frequency was, right? Now, how do we start building the cumulative frequency for the next bin? Well, it's the frequency of the bin we're looking at plus every observation below that, which we know everything below that, there's only one bin below it. The frequency of that bin is 36. So essentially, you would take the frequency of the bin you're looking at and add up all the frequencies from the bins that are below it. So here, we could do that by take the sum of these two, right? The frequency of the current bin and every bin below it, which is only one bin, right? Now we have the cumulative frequency, right? It's kind of like adding up, right? So we could continue to do this process. For this bin, we'll be adding up the frequency of the bin we're looking at plus both the bins that are below it. So it'll be 2 plus 7 plus 36, right? And we kind of continue this process. Now there's another way we could do this because I don't want to have to keep typing in this sum function every single time. And I can't copy it down because it's always adding more and more bins, right? As I get closer to the highest bin, there's more and more bins below it, right? But what I can do is I know, well, look, the cumulative frequency of this bin will be its relative frequency, or sorry, its frequency plus the frequency of every bin below it. But the frequency of every bin below it would just be whatever the cumulative frequency is of the previous bin. Right? And I'll give you another example of this here in just a second. I'll actually write this out. We'll get out of Excel. But I would take the frequency of the current bin, and I would add to that the cumulative frequency of the bin below it, which is not being friendly to me. So I know this is what, cell Q7, right? The one right above it, but for some reason this is blocking my view a little bit. And I get the same value, but now I can copy this down, and it keeps on taking the frequency of the bin I'm looking at plus the cumulative frequency of the bin before it, okay? Now notice, once I get to the very last bin, I'm up to the total number of observations. Well, why? Well, because once I get to the very highest bin, I'm trying to count up how many observations are in this bin and every bin below it. Well, that's every single bin. That's just counting up the total number of observations, right? Similarly, if I want to do a cumulative relative frequency, right? So let's say here, I want to do a cumulative relative frequency. Well, now all I'm doing is the same process, but I'm adding up the relative frequencies, right? Or if I'm making something relative, all I do is take the frequency and divide it by the total number of observations, right? It's kind of the same process as we used for the relative frequencies. We do the same thing for the cumulative relative frequency. It's just now, instead of dividing the frequency by the total number of observations, we divide the cumulative frequency by the total number of observations, right? So we go ahead and do that, copy this down. Well, once we get to that highest bin, the cumulative frequency should be 1, right? Because we should have counted up every single observation. Every single observation divided by the number of total observations is, divide something by itself, that's just 1. Okay? So that's how we would kind of create cumulative frequencies or cumulative relative frequencies in Excel. Okay? Any questions on that? This is kind of a little bit harder of an idea. I'll show you one more example here in just a second. Before I do, I just want to kind of show you how easy it is. If we want to then graph the cumulative frequencies or cumulative relative frequencies, I select my labels, hold Control. I'll select the cumulative relative frequencies here, insert. I could do it as a bar graph. A lot of the times with the cumulative frequencies, what we instead use is a line graph, just because it kind of provides a little bit more clear of a kind of growth up towards that value of 1, which should be what you get when you get to that final highest bin. Okay? All right, I'll show you one more way. I'm going to have these pulled up so I can see them as I'm working through this. So those of you on Zoom, just a second. I'm going to stop this. Hopefully, in just a second. I think it's frozen on me right now, but on Zoom, you should be able to, here in just 1 second, see the paper that I'm going to write on. If I can get anyone to either talk up or kind of type in the chat just to double check that you are seeing this. All right, awesome. So we can kind of think about it like this, right? If I've got my, and we'll do the frequencies just to make it a little bit easier. So we've got frequencies on the y-axis. And here's my bins. I think it was what, 0 to 2500, 2500 to 5000. And I'll just do the first few, and you can hopefully kind of get the idea. So this first one, I think, was something like 36, right? And I'm not going to get these numbers right, but it doesn't matter. It just matters that we have an example here. Let's say this was 5. Okay. What I'm doing with the cumulative frequencies for that very first one would be, let me zoom this out a little bit so we can get everything in there. There we go. Okay. I'm going to have the same bins down here. But now I want the cumulative values. Well, for the very first bin, we said it's just the frequency of the first bin, right? There's no bin below it. So that one's pretty easy. Right. For the second bin, we're going to take the frequency of that bin and add it to every bin below it. So all we're going to do is take the 7, add the 36, right, which would give us 43. Now for the next bin, we'll take the frequency of this bin plus every bin below it. Well, there's 2 bins below it now. So we'll take 5 plus 7 plus 36, right? Right, I'm taking this one plus both the bins below it. So if I do that, I get what? 43 plus 5. I'm up at 48, right? So that's one way to think about it. The other way, which is kind of the formula we used in Excel just because it was easier to copy down, remember, if I said I could also take the frequency of the current bin and add it to the cumulative frequency of the bin below it. So if I've got the frequency of 5 and I add it to the cumulative frequency of the bin that was below it, 43, sure enough, I get 48. Right? So there's 2 ways to do it. There's 2 ways to think about it. And if you wanted to in Excel, you could have kept using that sum function and just adding up the frequency of the current bin and every bin below it. It just takes a little bit more time, right? And it'll still work. You'll still get the right values. It's still a correct way to think about this. But another way to think about it is to get the cumulative frequency of the bin you're looking at, you'll take the relative frequency, you'll take the frequency of that bin and add to it the cumulative frequency from the bin right below it, okay? So that's just another way to kind of think about that. Are there any questions before we keep moving? I usually get a little bit of kind of confusion here. So if you have a question, don't feel like it's like you shouldn't be asking. Some questions on that? Okay. So switch back to the computer here. I'll take a little bit of delay, I'm thinking. There we go. Yep, awesome. Okay, so go back here. So we're back in that Excel file. What I want to do from here is show you a couple other things, right? So we've got, as far as I want to, kind of with this COVID data worksheet. The other thing I wanted to show that I thought I didn't have last class, because I didn't in this file, but I have it in the complete file. So if you go to that COVID data complete in Canvas and open that up, we've got a bunch of additional worksheets there. So one of them that I just thought was interesting, and I'm not expecting you to kind of do this, but I just wanted to show you some other useful tools we can do and use in Excel. So here, instead of looking at state level data, I just grabbed the total data from all states for different age groups. Right? I not only had it for COVID-19, I had it for pneumonia as well. So one thing I did was I just created pie charts, right, using the frequencies of different age groups, the frequency, the number of deaths from each one of these age ranges, and put them in 2 pie charts. You can kind of see that COVID and pneumonia deaths, the age breakdown. I mean, to me, you can't, visually, you can't tell any difference between these 2. So that's something that's kind of interesting. At least maybe we know that it's acting in a similar way as pneumonia, in the sense of it's the percent of kind of different age groups that tend to be affected most by it look like they're very similar, right? Which are kind of these older ages. We try to match up the colors. We'll see these are the older age groups. But another thing I could do, and it's pretty easy, so I could select my labels, the COVID-19 deaths, and then also, whoops, hold Control or Command on a Mac. Also select my pneumonia deaths and go to Insert a bar graph, and see it puts them right next to each other. And I can kind of see that it looks like, in terms of how it affects different age groups, it looks like COVID and pneumonia are really acting pretty similarly. Okay? And that's just some quick, obviously we're not diving too deep into the differences or the scientific differences, but at least from the number of people dying from both these things, it looks like it's affecting the same, or age groups very similar. Okay? On top of that, let me make sure there's no question. Okay. I have this other data set, which is healthcare expenditures and life expectancy, right? So we might think if a country is spending more, right, on its health, right, health expenditures are higher, maybe they're living longer, right? That might be a hypothesis that seems reasonable to have. So I can kind of check for the relationship between these two variables, health expenditures and life expectancy, by just taking these two, right? Select the two variables, and I did that with my mouse. Once again, another shortcut. I could hold Control Shift or Command Shift on a Mac, hit the down arrow, then hit the over arrow, and would select these two. Right? I could then go to Insert, and in my chart options, there's this one right here. It looks like it's got a bunch of dots, and it says Scatter. So we'll call this a scatter plot. We'll select that scatter plot option, and notice it basically graphs every single observation I have. And the x-axis will be whatever the first variable I select is, which here was healthcare expenditures. And the y-axis will be the second one I selected, which is life expectancy. And I think, I don't know, probably in some class, hopefully at some point you've heard of like a line of best fit, or if you have something that looks like this, if I try to draw a line that kind of best fits the scatter plot, it looks like it would be kind of sloping upwards, telling me that maybe there's a positive relationship between these, right? As a country spends more on their health, life expectancy goes up a little bit. Right? Now, this one's kind of interesting. We have this really weird observation out here, which, if you want to guess what country that is, get down here. I think I have it in the slides. It's actually the United States. This might not just be, so this is where we have to be careful, right? These two variables look like they're correlated, but it might not be causal, right? Maybe when you see higher healthcare expenditures in a country, it's because they need to spend more on their health, right? And so, if they need to spend more because they're not as healthy, we would expect life expectancy to be lower, right? We have to be careful about making this causal statement. All this provides evidence is that these two things might be correlated, okay? Another thing we can do in Excel, I have this US unemployment rate, and I have the graph already in here. I'm going to delete it so I can show you how I created it. If I've got data, and it's time series data, right? This is US unemployment rate collected in a bunch of different years. I'll select that variable I'm interested in graphing, unemployment rate. I go to Insert. I can create a line graph. And now notice the only issue with this, so it plotted it all nice. It's kind of, pretty easy to look at. The only problem with this is instead of the years down here, I've got numbers. So one thing that we'll do with these time series graphs is you'll go down to the x-axis labels, select them, see how it selects the numbers like in the dots. And actually, I told you guys to yell at me if I forget to zoom in when I'm switching sheets. So I right-click on those numbers after I've selected them. I then go to select data. There's a thing over here called horizontal axis labels. Well, what we want on that x-axis, or that horizontal axis, are the years. So we'll hit this edit button. We'll go over here, and we'll just select our years that we had in the data. We'll hit OK, hit OK. Now, we've got those years down there on our x-axis, okay? And the reason why these time series graphs are really useful, so if I had something like this, US unemployment rate, I can look at this and pretty quickly start to tell stories, right? I can say, well, look, mid-2000s, the unemployment rate was relatively stable, it was somewhat low, and then it started to increase in like 2008, peaked out in 2010, it looks like, and was on the decline ever since, right? Ever since 2010, the unemployment rate has just been dropping until this year, which, what's causing this spike? Well, a lot of people can't work right now, right? And so, but it very quickly, and right, if I saw this, I'm like, man, what happened in 2020 that you saw this huge spike, right? So just by looking at this graph, I can start to think I should look into like what happened in those years. I can pick up on trends pretty easily. Another nice thing would be if I had another country and I graphed that country's unemployment rate as well, I could then start to compare it to the United States, right? And all I would do there is if I had, I'm gonna make this up, but let's say I had Canada over here, I don't know, 3.5, 6.4, oh, I bumped something on my, there we go, 4.8. We could, just make up a bunch of values. So I'm just gonna go through here real quick, just so we have some data. 32, that's gonna be interesting. I can change this. All right. So the only difference I would have to do if I wanted both of these on my line graph is select them, right? And then go to insert my line graph. Another way I can do this, just because I don't want to erase those labels, if I right-click on the graph and go to that select data option, I can actually add, should be able to add this. I'm not going to like that. No, it's not. All right, we'll just do it the hard way. Select these, insert another line graph. See, now I've got Canada and the US here. I can change my years just like I did before, but it kind of allows me to see and compare like the differences. Now, obviously, this isn't real Canadian unemployment data, so it looks really weird, but I just wanted to show you can graph multiple time series lines on the same graph, and it's as easy as just selecting them, right? And then inserting your line graph, okay? Any questions before we kind of probably go back into the slide view for a little bit? Any questions on anything we did in Excel, or you want to see something again, or confused about something even from last class that we did? We're okay? Okay, now that complete one as well, you go here. I have things kind of that we did in class. I also kept the graphs in there. I put in a cumulative, frequency graph. I showed you what it would look like instead of a bar graph. We did a line graph. We could do a bunch of different things. And we had some things in class that we didn't do. So if we look at these slides, right, we could do a relative frequency polygon, which is essentially just a line graph instead of a bar graph, and we were graphing those relative frequencies. We talked about these cumulative frequencies already. I showed you the scatter plot. Here's just kind of a reminder of how you create it. Here's the time series. Here's a description. If you kind of forgot, you can go back and look at how we did that. And that kind of takes us through the Excel work that I wanted to do, okay? So I'll get the first Excel assignment posted later today. We might do a little bit on Wednesday. It'll be some really quick, easy stuff in Excel that you might need to do on that assignment. So you can get started on it. It won't be due for another 2 weeks. You can get started on it, the portion that's like building a histogram, but there's some things with like means and variances that I might ask you to do, and we won't have covered that until probably Wednesday or Friday this week, okay? But the majority of the assignment, we've covered enough to really get the majority of it done, okay? All right, so let me get this so I can see like that. There we go. Okay, so when we're building these histograms, remember kind of where we started out, we got lost in the weeds of Excel a little bit, but these histograms are really going to tell me something about the distribution of the data that I'm putting into this histogram. So when I look at these distributions, we're going to have 4 types of distributions we want to think about, right? The first is going to be what we call a normal distribution, right? So here I had SAT scores averages for different schools in Indiana. And kind of notice if I tried to draw a line that best fit the tops of all these bars, I'll get something that looks kind of like a bell curve. We'll call it a normal curve. And we probably won't really start diving into the normal curve for quite a few weeks. But once we do, we will be talking a lot about the normal distribution, okay? We'll be talking a whole lot about the normal distribution. And we see it pop up in a lot of different things, but more on that when we get there. What we might also see is something that looks like this. So this is income data. I know it's hard to read these labels, but they kind of put, I gave this example a lot last week of if we wanted to look at create bins for income, here's what it is, and then they kind of create this catch-all category at the end. That's why we see this kind of little uptick in the right side of the tail. But when we have this long right tail, right, if I try to draw a line that kind of best fit these bars, it's a very long right tail. We'll call this a right skew distribution. Now, we don't call it right skew because it has a long right tail. We'll talk a little bit more once we get into means and modes, exactly how this name came about. But an easy way to remember it is a long right tail, you've got a right skew distribution. Right? Here I've got some length of the pregnancy, so length or weeks of gestation. Notice it has a longer left tail. If I try to draw a line through this, there really is no right tail. It's very short, and then a long left tail, which kind of makes sense, right? We don't see children born at like 10 and 11 months, but we do see premature children born 5 to 6 months. So we've got this long left tail. We call this a left skew distribution. And then finally, the last one, anytime we see something like this, it almost looks like I have one normal curve here and another normal curve here. Right? We call this bimodal, right? Now this is body weight. So why do you think I almost have like two normal distributions here? What might be causing this? If I'm collecting data on a bunch of individuals and I collect their weight, why might I have two normal distributions for that?
Maybe there's like two different.
If I look at male weight, it actually is this nice normal distribution. If I look at female weight, it's a nice distribution over here, right? So a bimodal distribution usually means there's a characteristic in your data set that's really like two different groups, where whatever you're recording here, body weight, varies distinctly based off that characteristic, okay? Now, obviously, there's some overlap there, but just in general, right, we're comparing kind of the averages there. Okay, so we talked about how we create these distributions. The next thing we want to do is start to create single statistics that tell us something about the data. Right? So whether or not it's population data or sample data, what are some things we can calculate? Well, the first thing that we usually, and I've already mentioned it several times in talking about the distributions, but measure of central tendency, or where's the middle of the data? What's the most common outcome? What's the value that kind of takes on every observation and gives me one statistic that tells me, on average, what would I see for this variable? Well, we've got three different measures that will give us a central tendency of the data. We've got the mean, the median, and the mode. Right? We'll go through all of them in detail, but for now, I want to go over, we'll start writing some things in notation. Right? So here I've got these three statistics I want to calculate, and I represent them with this different notation. So for the mean, why do I have two here? Well, this first one, right, or mu, this is the Greek letter, and here I've got x bar, kind of our normal English kind of lettering system. The Greek letter, when we're using it for notation, always represents population, right? So this mu here, this is the population mean. X bar represents the sample. This is a sample mean, okay? Now, in terms of calculating it, we'll see there is no difference in how we calculate it. It just lets us know this mean is coming from sample data or this mean is coming from population data, okay? For the median and the mode, we'll just capital M subscript D for median, subscript O for mode, okay? Now, those are both capitalized. Those would represent the population. I don't think I actually have it in the slides here because we really won't use it much moving forward. But if I want to do the sample median or the sample mode, the only difference there is I use a lowercase m. Lowercase m subscript O, lowercase m subscript D. Okay? We also have measures of variation, which we'll talk about next class. But for now, I just want to show you the notation on them. So we'll have the variance and the standard deviation. The population variance is going to be sigma squared. Right? That's this Greek letter here is sigma. So sigma squared is our population variance. S squared, right, using kind of English lettering, that's going to be our sample variance. Okay. Same thing with standard deviation. Population standard deviation is just sigma. Sample standard deviation is just S. Right? So that's kind of the notation that we'll use for some of these descriptive statistics about our data set. So the first things that we'll start talking about today are measures of central tendency. Now, a lot of this will probably be fairly easy for some of us. But how do you find a mean? Just in, like, if you had to tell someone, how do I find a mean or an average, is typically what we would call this, but how do I find an average and the mean of a data, of a bunch of numbers? If I give you 5 numbers, how would you find the mean or the average? Yeah, you add them up and you divide by 5. So what are you really doing there? You're adding up all the numbers. So this summation sign, we're writing it mathematically, means start at the very first observation, go to the very last. So this capital N just represents the total number of observations in your population, right? Capital N will just be the total number of observations we have in a population data set. So go through, add all the numbers up, and divide by the number of numbers you have. That's what you just told me, right? If I have 5 numbers, I add them up and I divide by 5. That's all we're doing. We're adding all the numbers up. So we're taking the first number plus the second plus the third, so on and so forth, all the way to the very last number. And then we divide by the total number of observations we had in that population. Okay? That shouldn't be too bad, right? Like, we'll use these formulas. I'm showing you these formulas. I'm not expecting you to, like, ever necessarily write anything out in this. You need to kind of remember what the process is, and the formula hopefully will help you once we get to things like variance and standard deviation. The formula will help you remember what the process is, but especially for the mean, right? If this gets a little bit confusing, hopefully you can remember I'm just adding up all the numbers and dividing by the total numbers I have. Okay? The sample mean, we'd write it the exact same. It's just now the notation, instead of using the Greek letter mu, we're going to use x bar. Sample mean, it's the same thing. It's just now we add the numbers up and divide by the total number of numbers in our sample data. So lowercase n represents the total number of observations or the total number of numbers in our sample data set. So it's the process is no different. The notation is just a little bit different. Instead of capital N, we're using lowercase n. Okay? Excuse me. So that shouldn't be too bad. So if I was thinking about, like, how would I find the mean birth rate in the United States? So I have this data set. It's got every birth that's ever been, recorded in the United States. All I would do is go through, add up every single birth weight, and divide by the total number of births I have in that data set, right? And hopefully you can start to visualize, since we've done a little bit of work in Excel, that would be pretty easy to do in Excel, right? If I had a column of data, I could equals sum, select that variable. It would add up every single number there. And then how would I get the total number of observations? Well, we said we had that count formula that would just count up the number of non-blank cells. So now I've got the sum of all those birth weights. I've got the total number of births in that data set. I just divide, that sum by the total number of observations, and I'd have my mean. Right? Now, if I want to do this by hand, right, that's going to be a pain, especially if it's like every birth in the United States or something. So this is where Excel really starts to be powerful and useful for us. Okay. And I think I actually had some data on that, and so I want to do that. I'll probably show you that file next class if we start to work with how do we do the mean in Excel. I'll show you some examples, but we'll hold off on that till next class. All right. So if I had a small data set like this, right, how would I find the mean? It's pretty easy here. I don't know what game this is. It could be basketball, it could be boggle, it could be anything. But I've got 7 different games that were played, and I've got the points that were scored. So if I want the population mean for the points scored from this data set, all I would do is go through, add up all these numbers, and divide by how many observations do I have here? Pretty easy. I've got 7, right? 7 games. So add these up, divide by 7, right? Pretty easy, all right? So I probably can expect in the online quiz I post after class today, a pretty easy, simple kind of question like this, right? Give you a small data set, calculate the mean for me, okay? So here's another example. It's the same kind of idea. It's really no difference. I've got commuter time instead. How would I find the mean commuter time here? I just add up all these values. And I kept the data set the same size here, so I'd actually still divide by 7, right? So that's 7 observations. Might look something like this on the online quiz where I give you the answers. You then go through, use this formula, add up all those numbers here, divide by the total number of observations, should give you the answer 45. Okay. Now, one thing to be careful about, I had someone email me about the Friday's quiz. I might say that the online quiz question will look similar to this. I will probably change the numbers. So don't like just look at what we did in class. Like I'm glad you're paying attention in class and writing down what we're doing, but I might change numbers in that quiz from the examples that we use in class. So be careful kind of as you're working through those. But here's kind of two nice examples for that question that you'll be asked. All right, where are we at in time here? Oh, we're good. Okay. So the next measures of central tendency, the mean is a good measure, but there's a little issue with it, right? There's a little problem with the mean, which is that it's really, really greatly influenced by extreme values. So I'll show you an example here in just a second, actually, just in Excel. So I'll use the paper and pencil. But the median and the mode won't be as influenced by extreme values, right? So the mode is just going to be the measure of what value occurs the most. So I look at my data set, what number do I see the most, right? Which one has the highest frequency, right? I look for the value that has the highest frequency, and that's my mode, okay? The median is going to be the value that exactly cuts my data in half, such that if I look to the left and to the right, or I look above and below that value, there will be 50% of my observations above it, and 50% of my observations will be below the mean, right? So the mean doesn't necessarily always do that. I think people think that it does, but it doesn't necessarily fall exactly in the middle of the data set. And I'll give you a quick little small example here in just a second to end class. So how do we find that median? Well, we basically, if we lined everything up from smallest to largest, and we just start crossing off the highest value and the lowest value, then cross off the next highest, the next lowest, and continue that process until we're left with one observation, that value would be the median. Now that process works fine if we have an odd number data set, because we're crossing off like 2 at a time and then we'd be left with 1. But if it's an even number data set, we get to the last 2 numbers and we'd be crossing both of them off, there's nothing left. So if it's even, when you get down to those last 2 middle numbers, all you do is find the average of those, right? Find the mean of those last 2 numbers. So I'll show you an example here visually of how you would find the median. Or actually, I think here, we do the mode and the median. So first of all, if I look at this data set, and this sometimes happens, a little bit of a trick question here. What's the mode here? Oh, actually, it's not a trick question. This one's pretty easy. What's the mode here? Remember, the mode is the value that happens the most. There's only one value here that happens more than once, which is 35. So every other value we only see one time. The mode occurs twice. And so we would say the mode here, the most frequent value that we see, 35, that's our mode. Okay. What if I wanted to find the median? Well, this is where I start to, oops, there we go. I start crossing off the highest and the lowest value. So I look here, the lowest value is 15, the highest value is 35. I cross those off. The next highest, next lowest are what, 16 and 35, so I cross those off. Next highest, next lowest, 18 and 28, I cross those off. I'm left with, I have an odd number data set, I'm left with the middle value of 20. So 50% of the data is above and below that, right? There's 3 observations that were above 20, 3 observations that were below it. If I had an even number data set, let's say I had an 8th game and they scored 22. Well, I'd be left with the 2 values of 20 and 22. To find the median, I would just find the average of those, or find the mean, so add them up, divide by 2, and it would be 21 would be my median. Okay? All right, any questions on that for you? Kind of keep moving. I'm going to switch this here and kind of give you an example of why maybe sometimes we'd rather have that median than a mean. Okay? Let's have a small data set. And I don't know, say it's like 2, 4, 6, 8, and 10. Right? If I want to find the mean, I add those up and divide by the total number of numbers I have, which is what, 5. So I add all those up, I get what? 30 divided by 5. So I get a mean, we'll say it's population data. We get a mean of 6, right? That shouldn't be too tough. That's pretty easy. What would the median of this data set be? I cross off the highest, lowest, highest, lowest. I'm left with 6, right? So a median of 6. So here, both of those values, or both of those statistics are a good measure of the central tendency of this data. But what happens if instead I had a data set that looked like this? Oops. I have one really extreme value there. Well, if I find the mean here, it's what? 20 plus 100, so 120 over 5. So I get what? 24. Am I doing the math in my head correct here? Yeah, I've got it. So we've got our mean of 24. What's my median? Still 6, right? And that's because the median is unimpacted by this extreme value because I'm just crossing it off. But the mean, right, when I'm adding these values up, that number gets added in to that formula. And so notice, if I use this as my measure of central tendency for this data set, well, there's 4 observations that are pretty far below this, and one that's really, really far above it. So it's not really giving me a good idea of what the majority of those observations, what the values are, right? And really, this is a big issue when I have small data sets, right? The larger the data set I get, an extreme value doesn't impact that mean as much. But with a small data set, these really extreme values can greatly kind of skew our mean away from where the majority of the observations are, right? And so there, the median might be a better measure. And we'll kind of next class compare these and kind of look at some distributions where the median and the mean are different from each other and talk a little bit more about that. And actually that will allow us to figure out why, when we were thinking about those distributions earlier, why they're called right and left skewed. It's not because they have long and right and left tails. There's actually another reasoning behind it. Okay? So talk about that next class. I see something in the chat here. Oh, there's some other question. Oh, I want to stop the video. Sorry about that. I just wanted to switch the video. So, talk a little bit about medians, modes, means. I'll get an online quiz posted after class today that'll probably have a couple questions related to those 3 things. Next class, what we're going to do is start, we'll finish the discussion here relating this to distributions, right and left skewed, and then we'll start on measures of variation, right? So the variance and the standard deviation. Okay? It'll be a little bit trickier than the mean, median, mode. Those are quite a bit easier. But we'll start with that on Wednesday and maybe do a little bit of stuff in Excel where I show you how you can create or calculate variances and means in Excel pretty easily. Okay? I'll get that first Excel assignment posted today as well. Like I said, you'll have 2 weeks before that's due. If you guys have any questions, please email me. If you want to set up a time to meet me in office hours on Zoom, email me that as well. I haven't had anyone taking up an offer yet. We're not too far into things yet. I'm sure as homeworks get closer to being due, I might get a few more of you to reach out. But please don't feel like you can't do that. Okay? Any questions before I let you out of here? All right. Like always, I'll leave the Zoom open for a little bit. So if you guys have questions, you can ask or type in the chat box. Other than that, I will see group 2 on Wednesday, and I'll see you guys group 1 if you want to show up again on Friday. Okay?